Now, let's look at the details of our experiment. Remember the method that I explained in the first clip. We use a fixed value of mass capital M. For the hanging mass M, we use 4 to 5 values of M. And for each value of M, we do the experiment to measure the corresponding acceleration A. When we complete all the measurements and calculations, we then plot a graph between the acceleration A and the mass ratio, which is lower m divided by capital M plus lower m. Look at the figure. You may read the procedures in your book along with my explanations. We let the mass capital M start its motion from rest at the position x0. There is a photo gate at position x0. Next, we let capital M move a distance of 70 centimeters from point 1 to point 2. At position 2, we place another photo gate. It is a part of the timer system. We want to measure the speed Vf of mass capital M when it passes position 2. By definition, the speed Vf is the distance L it travels in a time duration t1. We must consider the situation at position 2. Suppose our object has a length of L. When it's past the photo gate 2, the photo gate records the time t1. The object moves the distance L. We repeat this motion by pulling the system back to position x0 and repeat the motion. We do this 3 times to get the average value of t1 average. We can then determine the value of Vf. Next, we measure the acceleration A. We use the definition of acceleration, which is the final speed Vf minus initial speed Vi divided by the time the object moves from the initial point to the final point. Let's call this time t2. We do experiment by letting the object start from rest at position 1 and moves to position 2. We have to pull the system back to the initial position x0. And then let the system move from point 1 to point 2. The timer system records the time t2. We do this 3 times to obtain the average time t2 average. Then we can calculate the acceleration A according to the equation. You repeat all these procedures for another values of lower m. and measure the values of Vf and the acceleration A. When completed, you can then plot the graph between the acceleration A and the mass ratio. The plot has 5 points because you did measurement 5 times. Then you can fit the baseline to your plot. Draw the baseline. The line should pass the origin of the graph. The line should be drawn in such an average way. Now let's look at the arrangement of our experiment. The pictures in your book are similar to the ones you see here. This is an air track. We use an air blower. Air flows into the air track. The air track has small pinholes through which the air can flow out. This makes the motion of an object on the air track frictionless. This combination of a glider, the added masses on each side of the glider, the blade, and the plaque is our object of mass capital M. The other end of the rope is the hanging mass M. The mass M includes the mass of the hanger and the added mass piece. The mass capital M is fixed. We can weigh it later. For the hanging mass M, we add 5 grams or 10 grams pieces on the hanger, which is 2 grams. The first value of M is 7 grams. We place 2 photo gates at position 70 cm and 140 cm on the air track. So the distance between them is 70 centimeters. We place the mass capital M at the start position 140 centimeters. We record this position as x0. The value of L is the length of the braid on the glider. The length is 10 centimeters or 0.1 meter. The value of capital M, we can weigh it later. For the hanging mass, the first value is 7 grams or 0.007 kilogram. The mass ratio in the second column is to be calculated later. Next, we want to measure the time t1 that the object takes to pass the photo gate at the final position. We measure this 3 times to find the average time t1 average. Let's observe how to start the motion and measure the time t1. When ready, switch on the air blower. The system starts to move from rest. The photo gate records the time t1. If we know the distance L, which is 10 centimeter or 0.1 meter, we can then calculate the speed v. V is the length L, which is 0.1 meter divided by time t1. In the calculation for V, we will use the average time t1 average from 3 measurements, like this. Then we can calculate Vf. Here we write as V. Next, we'll repeat the experiment by adding mass to m, 5 grams at a time, from 7 grams to 12 grams, 17 grams, and 22 grams. And each time, we measure the average time so we can get the average time t1 average. Next, we want to find the acceleration A. The acceleration A is the difference between Vf and Vi. In our experiment, Vi is 0, and we let Vf equals V that we have already obtained. And divided by t2, the time t2 is the time the object moves from point 1 to point 2. We pull the system back to position x0. The arrangement is the same as we did the experiment to measure the time t1. The values of the hanging mass are the same. For the measurements of time t2, we use 2 photo gates. The first photo gate triggers to start the timer. When the object reaches the second photo gate, the timer stops. We need to change photo gate connections. There are procedures in your lab direction book. Now we are ready to measure the time t2. Let's look. We switch the blower on. The motion starts. The timer starts. When the object reaches the second photo gate, the timer stops. Switch off the blower. This is the time t2 on the display. We repeat another 2 times to find the average time t2. T2 average. After this, we repeat the same measurements for another 3 values of mass m. Next, we use the T2 average to calculate the acceleration A. A is equal to V divided by T2 average. Now we have all the data needed. 4 values of the acceleration A and the 4 values of the mass ratio. We take the data in the 2 columns to plot a graph between the acceleration A and the mass ratios. Let the acceleration A be on the y-axis and the mass ratio be on the x-axis. From your graph, you can calculate the slope of the graph. The value of the slope is the value of the gravitational acceleration g that we want to determine. To calculate the slope, you choose point 1 and 2 on the fitted straight line. The rest of the work are, for example, the calculation of percentage difference of the measured G and the standard G value. Answer questions. And finally, conclude and discuss the results of your experiment. You may discuss about how large the percentage difference is, sources, errors of your measurements, and so on. So, use the data you have seen during this explanation and do the rest of the work in your report sheet.